Tidal energy, you'll find most importantly, is very friendly to the environment. Harnessing the power of the tides produces virtually no pollution, and none of the harmful byproducts that are usually associated with burning oil or coal or fuel are derived from using tidal energy, since tidal energy mainly just gets its energy from the alteration of high and low tides. That's why we are here to sell our pitch to you, the sharks, who are on the verge of making an investment on the greenest technology ever. Under normal Earth circumstances, this tidal pool may have a few negative effects, such as disrupting marine life's natural migration patterns, but that shouldn't be a problem on Mars since there is no marine life. And to put the cherry on top of it, using tidal waves has absolutely no adverse effects on human health.
Tidal energy is still being researched and tested every day and still has some unknown aspects of it. For example, companies from around the world have found ways to use tidal energy to make clean, reliable power. Because of this, the developing turbine structures are making the generation of electricity from ocean energy economically and technologically reliable. With proper research, tidal energy could become a new, reliable, renewable resource, replacing the need for fuel-based resources, and tidal power is an environmentally friendly energy source. Tidal energy also does not emit any climate gases and does not take up a lot of space. In addition to getting rid of the massive carbon dioxide production, which is a main contributor to climate change, tidal energy also decreases the risk of spills associated with fossil fuel extraction. It is clear that we need an alternative energy resource because almost 70% of the United States' demand for electricity is currently fulfilled by fossil fuels. In many ways, the environmental impacts of using tidal power are similar to those of offshore wind power generation. These impacts include changing of substrates, alternation of waves and sea currents, noise pollution during the installation and operation, alternation of ecosystems for regional organisms, intrusion upon animal migrations, and potential strikes by any moving parts of the tidal system. Further effects on biological ecosystems could refer to the changing of animals' behavior. Overall, tidal energy is mostly economically friendly, but still has some disadvantages and is a very reliable source of energy.
Tidal technology is considered the most reliable and most efficient source of energy right now, and this is because it's very predictable. Tidal energy is dependent on the moon because the moon is what creates tides, and so because of this you can predict where tides are going to occur, when the tides are going to occur, and how strong the tides are going to be, which are all very useful information in terms of the generation of energy. There are three types of tidal technology right now. The first one is a tidal stream generator. Tidal stream generators work the exact same way as wind turbines, except they're underwater, so they use ocean currents instead, and they collect potential energy, and the potential energy goes through a generator. It's generated into electricity. The electricity goes through wires into the city, and so that's how the city will get its energy through the tidal stream generators. The second type of tidal technology is called a tidal barrage, and so the way this works is that it's a dam that's kept in a specialized area, and it has this gate called a sluice gate, and so when the tides are high, they use the sluice gates to control the flow of the tide, and there's a turbine underneath that captures all the energy, and that's how energy is provided through a tidal barrage. The third type of tidal technology is called a tidal lagoon, and it works the exact same way as a tidal barrage. The only difference is it's more eco-friendly because a tidal barrage can cause a lot of habitat destruction since dams aren't very good for the habitat. Tidal lagoons are kept near coastlines with very high tides, and so it takes up less space but provides the same amount of energy.
In this chart, we will be comparing the expenses of 4 different types of power plants, which are nuclear, fossil steam, gas turbine, and small scale, and hydroelectric power. Tidal wave energy falls under hydroelectric power, and we can tell in this chart that hydroelectric power actually is the cheapest to operate. This is probably due to the fact that hydroelectric power operates through the use of water, which is the fuel. So the hydroelectric power cost of fuel is essentially nothing because it uses water. In this chart, we will be comparing hydroelectric power to other types of power plants, this time including renewable sources of energy such as wind, solar, geothermal, and biomass. And we can tell in this chart that hydroelectric power falls on the cheaper side, although it does not prove to be the cheapest option. However, It is important to note that although hydropower is not the cheapest, it is operating currently at an average of 80 to 90% efficiency, meaning it takes the kinetic energy and converts 80 to 90% of that straight into electricity, whereas its main competitors and some of the other forms that are cheaper, such as solar, geothermal, and wind energy, actually produce on average 10 to 30% efficiency, which means they convert only 10-30% of the kinetic energy into electricity, which makes them much less efficient than the hydroelectric power alternative. The only other source cheaper than hydroelectric other than solar, wind, and geothermal would be natural gas on this chart. And we can tell that the natural gas actually exposes water sources and air to pollution, whereas hydroelectric power causes no pollution and can be the best source of energy because of this.